Hello and welcome to this video about simplifying rational expressions. The learning target of this lesson is knowing what a rational expression is and when it is simplified. So first of all, let's talk about it. What are rational expressions? So anytime we see the word rational, we have to think about the word fraction. And so rational expressions are fractions. And technically a number, like 1/2, is a rational expression. But what we're getting at in algebra, so what we're going to do is insert another word here. And that word is algebraic. So what are algebraic rational expressions? Well, it's still going to be a fraction, but with a variable expression, either in the numerator, denominator, or both. So, for example, 1 over x is a rational expression. X squared over x plus 3 is a rational expression. Or we could kick it up a notch. X squared plus 5x plus 6 over x squared plus 7x plus 10 is a rational expression. And so this is what I'm getting at. We are dealing with something that has a variable in an expression form that's in a fraction. And so what we have to do is figure out how to simplify these and that point is where we're done. We don't need to go any further. So let's talk about a few core ideas here. We have several of them today. The first one is that this is not allowed. So you cannot have a number or an expression and then a 0 in the denominator. And what happens is whatever value makes the denominator 0, we'll abbreviate this D-E-N, denom, equal 0 is an excluded value. So for example, if we look at something like 1 over x plus 2, we cannot let that denominator be 0. And the only value that's going to make that be 0 is x is -2. So what we're going to say is x cannot equal -2. So that's one core idea. Second core idea plays off of that. Is that if you have 0 over some number, that equals 0. And so if we want to find the zeros, you set the numerator equal to 0. So set numerator, which will abbreviate just numer, equal to 0 to, and then I'm going to put this in quotes because you see it in directions, find the zeros of the expression, of the equation, of the function, whatever they're calling it, whatever the context is, you set the numerator equal to 0 to do that. Just because anytime 0 is divided by a number, it's going to equal 0. All right, and then finally, the other core idea is how we're going to go about simplifying these. And so we're going to use either rules of exponents or factoring to simplify. So those are the three core ideas I wanted to get across about rational expressions. First of all, the denominator cannot equal 0. Second, if we want to find the zeros, we set the numerator equal to 0. And third, we use rules of exponents or factoring to simplify. So now let's jump into some examples. Our first one is going to be a simplifying one. And so let's say we have 16a squared b to the 4th over 8a to the 3rd b. So here we can obviously simplify. If we just even look at the numbers, we can simplify. So take it one component at a time. Start with the numbers, then work your way to the a's, and then the b's, or whatever the letters happen to be. So here, I'm going to get 2 over 1 for 16 over 8. And then when I look at a squared and a cubed, I could do rules of exponents, or I could also just realize, hey, there's 2 of these a's here. They're going to completely go away, and they're going to leave me with 1a right there. And so I will have 1a in the denominator And then a similar sort of thing is going to happen with the b's, where this b in the denominator is going to go away, and it's going to eat up one of the 4 and leave me with 3. You could also use rules of exponents, 4 minus 1, 2 minus 3, to figure all this out. And so 2 ways we could write it, depending on, and it depends on which textbook you're using. We could go 2b cubed over a. We could also say, or, and this is probably not necessarily what a lot of books are going to look for, 2a to the negative 1b to the third, because usually textbooks don't like negative exponents. So either one, I mean, they're technically the same thing, but the one on the left is a little cleaner. Let's look at a second example. Let's say we have x plus 3 over x squared plus 10x plus 21. All right, so with something like this, we're going to use our factoring. And we're going to expand this, and we're going to get the x plus 3 in the numerator still. But when we factor the denominator, we could first of all use this as a hint. If this is x plus 3 and we're simplifying, odds are x plus 3 is going to be one of the factors in the denominator. And take a look at it, it is, because if we let x be 3, then this one has to be 7. 7 plus 3 is 10. What a coinkydink, right? But now, keep in mind, this x plus 3 in the numerator is in parentheses, it's just invisible parentheses. And now these guys can be reduced. And we're leaving us with 1 over x plus 7. And then if you were asked, like what values would you have to exclude from this? In the first one, a cannot equal 0. And in the second one, x cannot equal negative 7. And to do this one right here, I just went x plus 7 is equal to 0, and I solved that in my head to get x equals negative 7, and then realizing it can't be negative 7. So that's how we simplify, either using rules of exponents or by factoring. So let's do one more example. So in this one, we're going to have an expression, x squared plus 2x minus 15 over x plus 1. And what we want to do is find the zeros and excluded value. So the zeros are going to come from the numerator, and the excluded value is going to come from the denominator. Now the first thing I'm going to want to do is factor, see if anything cancels out here. So let's see, x and x, factors of 15 that can get me 2 are 5 and 3. I want a positive 2, so it'll be plus 5 minus 3. And then x plus 1 can't really be factored. And nothing gets canceled. So this is as far as we can go. Now to find the zeros, again, I'm going to take these and go x plus 5 times x minus 3 is equal to 0. I'm going to break these up into two separate equations. X plus 5 is equal to 0. X minus 3 equals 0. So the zeros are at x equals negative 5 or at x equals 3. This one could also be an and kind of a situation. As for the excluded value, I'll take this one, x plus 1, so that equal to 0, and x equals negative 1. And so two ways I can write it. I could say, x equals negative 1 is the excluded value, or I can just say x cannot equal negative 1. It has the same idea. So negative 1 is a number that we really care about, and when we let x equal it. And so we either have to say it could be anything but that one, or just cannot equal that one. Anyways, that is just simplifying rational expressions in a nutshell. Just to kind of wrap things up here, I'll give you one final tip, which is just sort of, think fractions. Because again, that's all these things are, is that they are fractions with variable expressions. And so if we were to do something like 3 plus 5 over 3, you couldn't, think about how you would simplify that. And how you can't take a 3 out of everything, so maybe you don't really simplify it. You let it be what it is. And that's the exact same idea as having x squared plus 2 over x. You can't be like, hey, I got an x here, I got an x there, or even if we got rid of like this x squared, we just can't be like, all right, let's get rid of those x's. It doesn't work like that. There are parentheses that are around this x plus 2 and around this x, and what's inside the parentheses has to match up exactly. If there's nothing else you can factor, and there's nothing that can be crossed out, you've simplified it. Then the other thing I want to remind you is just sort of the whole zeros. So the zeros are going to exist up here, and you do that by setting whatever's up here equal to 0. And then the excluded value, which I'll just abbreviate EV, excluded value, is going to be down here. And again, you set whatever the denominator is equal to 0 to find that. Good luck with your homework, and let me know if you have any questions.